Students, in this session we will discuss about the measurement of head of water generated by a hydraulic pump and the measurement of head of water acting on a hydraulic turbine. This photograph shows a centrifugal pump test rig available in the laboratory. This is the pump whose performance we want to measure. For the measurement of performance of the pump, we need to measure the water power generated by the pump. So the water power is given by WQH. W is the specific weight of water, Q is the discharge, and H is the head. So here there is a need to measure the head of water generated by the pump. For the measurement of the head of water generated by the pump, we use two pressure gauges. So these are the two pressure gauges that are fitted to the delivery side and suction side of the pump. One pressure gauge is recording the pressure at the delivery of the pipe. One pressure gauge is recording the pressure at the entry to the pump. These two pressure gauges are shown here clearly. The delivery pressure gauge is calibrated in terms of kilogram force per centimeter squared on the outside, and the inner ring is having the pressure calibrated in some other unit. We will use the outer calibration shown in black color in this example. Similarly, the vacuum pressure is recorded by this vacuum gauge. There are two dials. The outer dial is recording the vacuum pressure in mm of mercury, whereas the inner dial is calibrated to record the pressure in some other unit. Let us say the pump record a delivery pressure of 1 kilogram force per centimeter square and a vacuum pressure of 200 mm of mercury. How to convert these two pressure gauge reading into head of water, we have to discuss. So the delivery pressure is 1 kilogram force per centimeter square. You have to convert into Pascal by multiplying with 9.81 and 10 to the power of 4. So 1 kilogram force per centimeter square is equal to 1 into 9.81 into 10 to the power of 4 Pascal or Newton per meter square. Let us use this formula P is equal to rho G gauge to convert the delivery pressure gauge reading into head of water. So from this, H is given by P by rho G. So the P is what is recorded in Pascal, 1 into 10 power 9.81 into 10 to the power 4, and the rho G is the density and acceleration to gravity. So the rho of water is 1000 and G is 9.81. So we are reading of 1 kilogram force per centimeter square shown by the gauge is converted into 10 meter of water. So this is how you are going to convert a pressure gauge reading of 1 kgf per centimeter square into head of water. Similarly, a vacuum gauge reading 200 mm of mercury is to be converted. So the PS is 200 mm of mercury. We will use a different formula. P equal to rho G gauge measured in terms of water column is equal to rho G gauge measured in terms of mercury column. So the pressure can be measured either in water column or mercury column or in any fluid column. So we will use these two equations. We will equate these two to find out the head of water at the suction side. So the G and G are both gets cancelled. So rho of water into H of water is equal to rho of mercury into H of mercury. So that is what I have written here. From this, what we need to find out is we want to convert the vacuum gauge pressure reading into a head of water. So HS or HW is what we want. So keeping this alone on the left side, I am bringing everything to the right side. So rho of Hg, H of Hg, thereby rho of water. So if you use this formula, you can be able to convert a vacuum gauge reading into corresponding head of water. So H is equal to rho of Hg, H of Hg and rho of water. So here rho of Hg is density of mercury 13,600 and H of Hg is what is shown by the vacuum gauge. So it is showing a reading of 200 m of mercury, that is converted into 0.2 meter of mercury. So 200 m of mercury is converted to 0.2 meter of mercury. So divided by rho of water is 1000. Density of water is 1000. So when you substitute everything, you find the suction pressure as suction head as 2.72 meter of water. So the delivery head is 10 meter of water, suction head is 2.72 meter of water, both are getting added. So the total head generated by the pump is the sum of the HD and HS. So delivery head and suction head. So 10 plus 2.72, 12.72 meter of water. So this how we have to convert the pressure gauge reading into head of water. Let us see how to convert or how to find out the head of water available for running a turbine. A turbine converts water power into mechanical power. So the water power is the input and mechanical power is the output. Water power is the input and mechanical power is the output. So the water power has to be measured means we have to measure the head, we have to measure the discharge. For measuring the head, we have used two pressure gauges in this experiment. Instead of Bourdon gauge, pressure transducers are used. One at the inlet to the turbine, one at the exit to the turbine. So these are the two pressure transducers used to record the pressure of water entering and leaving the turbine. The digital display shows the pressure of water sensed by the pressure transducer at the inlet and the pressure of water sensed by the pressure transducer fitted at the exit of the turbine. So this is recording PD, pressure of water entering into the turbine. This is recording PS, the pressure of water leaving the turbine. We can use the same formula what we are using for finding the head of water for a pump. So the PD is shown by the display, let us say 1.2 kgf per centimeter square. It is converted to 12 meter of water using the formula already discussed. Similarly, the PS, the suction pressure or the pressure at the exit of the turbine is 30 m of mercury. It is not suction pressure, it is pressure at the exit to the turbine. It is regarded as 30 m of mercury in this example. So you can use the formula what is used for the pump. It is converted to 0.408 meter of water. So both the head of water are added, 12 and 0.408 are added. So the total head of water available for running the turbine is 12.408 meter of water.